Deadband and hysteresis are two different things, although they both typically cause nonlinearities and problems in process control. The author of the text we're using confuses the two, conflates them, and also makes a tie-in to dead time that I don't really agree with. Let me try to illustrate these two a little bit better. There's a paper I found that I've posted in Brightspace by Fisher Controls, which I believe was either bought or merged with Emerson's because it has Emerson's name on it. But Fisher Controls, if you're not familiar with them, have made control valves for quite a long time. They're a good control valve, and basically they are pneumatically operated valves for controlling fluid flow. You can see one in cross section here where the diaphragm is at the top. You can see the springs for returning the diaphragm to one particular position, and therefore the stem, because you can see the yellow stem connected from the diaphragm actuator all the way down into the body of the valve. And of course this is a process control valve. There's even a little sort of dark gray or black box there that's probably supposed to be some type of positioner. If you notice, the stem goes down into the body of the valve, and so that stem has to be sealed because you got some type of fluid flowing in the valve, whether it's a gas or a liquid, whatever the case may be. There's always something called packing that's required around the stem, and that packing seals the motion of the stem so that the fluid doesn't leak out of the control valve as the stem can move. So the problem, of course, is that there's a lot of friction there. There's a lot of friction between the stem and the packing. And so when you try to get the valve to move initially, what happens is it doesn't move. It takes a certain minimum amount of force to overcome static friction. And then once it's moving, then there's kinetic friction and things can move. But the primary behavior here is actually deadband, where when you're trying to go from either still or going from one direction and reversing direction, you have some range of input, in other words, changes in the air pressure signal, over which there's no change in the output. So there's no change in the flow rate through the valve. As you say, increase and increase pressure, nothing happens, it sticks and then eventually slips. And that is a classic deadband problem. And you can imagine can cause all kinds of process control difficulties. Hysteresis, on the other hand, has more to do with a particular input giving two different outputs depending on which direction you're going. Now, of course, deadband looks the same way. Deadband looks that way, but hysteresis has more to do with things bending and not recovering fully, or a difference in output, a measurement on the y-axis of output, not so much a dead band for input. The example I gave about the old Ford vehicle going down the road and the steering wheel being able to move by about 20 degrees back and forth without any change in the steering wheel's position, that would be an example of deadband, really, is what that is. And so there is a difference between hysteresis and deadband. Often on control valves they're just lumped together because both exist. It's just deadband is the more prominent nonlinearity. So both cause problems. Now, on the other hand, sometimes with on-off control, deadband or hysteresis is necessary, particularly deadband, so that the system doesn't cycle on and off continuously. But of course our interest is in continuous controls. So if you think about a typical control valve with, say, just an integrating controller, let's say that you need the process variable to be right at the set point, and so you notice there's a difference between the set point and process variable, so the integrating action makes the pressure in the valve go, or in the diaphragm go, higher and higher and higher, and then all of a sudden it slips, and then the process variable moves above the set point, and now the integral action has to go the other way. It's got to integrate the negative error or the opposite error to what it had before, and you get this continuous slipping and sticking behavior where the valve never really hits the set point. It just keeps dancing around it. And this is a very common feature to see with control valves where this problem hasn't been resolved, where there is so much friction. Now, to overcome this, what's commonly done is a positioner is used with two different loops of control, but that's beyond what we're talking about right now. So overall, what we saw were that there are different types of processes to be controlled. We understand hopefully better the idea of some steady-state process gain and the fact that all the elements in the control system have some type of gain. And then understand that some of the issues are things that cause delay or that cause deadband and hysteresis, and that there is really a difference between deadband and hysteresis.